Check, check. Hello, everyone. I'm just doing a easy, calm live stream today of a Smart 5 for you. Hopefully, some people that have been having some questions can have a chance to pop in, but we'll see how it goes for today here. I'm just getting things set up, so sorry I didn't schedule this one ahead of time. Let me make sure I'm not blowing your guys' ears out on the microphone here. So let me know if things are too loud or not too loud, or if I'm not loud enough. I'm trying to watch my mic input here for you guys. Hey, Daniel. Hey, Sean. Oh, it's going good. It's been a really busy week, so excuse me, it looks like I gotta adjust my volume just a hair. You guys will have to let me know how things are coming through. It's been a little while since I set up a live stream, so oh, thank you, Daniel. Um, I did not schedule this one, guys, so you'll just kind of have to bear with me here. I think I'm all set though. Got my coffee in one hand, got the meters in the other. So I hope you all are doing okay, staying healthy out there. It's been pretty interesting here in Washington, so I'm still kicking. That's all I got to say. So this Smart 5 is in Protect. The customer states that it's it just blinks. So when you have a Smart 5 and it's just continually blinking, that's telling you that there's a problem in Protect. That's what I love about these smart amplifiers. The blinking sequence will kind of give you an idea what's going on. Oh yeah, you bet, Daniel. I always thank everyone for dropping in. I've been having a heck of a time trying to get videos edited because I've been just so busy. This is a warranty repair, so I think a lot of people are just getting ready for the competition seasons that are coming up. I got several customers that need their stuff done by April, so I get them in, get them out. It's typical 7 to 10 days for me. So this one here, let me just show you guys here. There's a lot of questions about how I do things, and that's kind of why I decided to go towards a live stream today versus a record and edit. So hopefully, like I said, the guys can drop in if they have questions on how I do things. So most every transistor has a gate resistor and a pull down resistor. Sorry guys if you hear my furnace kick on in the background and turn off. And that's one of the biggest questions I get is I use resistance for most all my testing. No, this is just a Smart 5. So this is just, it's called their Smart line. So you have a Smart 3 and a Smart 5. So it's not, hey Damon, good to see you there. Hopefully you got my package there, Damon. If not, let me know. But yeah, this is the Smart version. So it's the Smart 1 to 2 ohm. I think I've said it before in the past, so what makes it smart, I don't know. I haven't dug that far into these. I just don't have a lot of time to really reverse engineer, you know, how the logic of these functions. So so this power supply is good. So on these tar amps, you'll see that you will have 1K between the gate and source. Uh, they make a base version of the Smart. Oh, I've from every Smart amplifier I've got in, it's either a Smart 3 or Smart 5. So uh, this is the revision 0 Smart 5. Unless I'm missing something. So again, so you're gonna find that you're gonna have your 1K across your gate and source on your power supplies here. And what I look for is the value across the gate and source. So over here, I have 20.25 ohms on this transistor. Man, I'll just take a random reading. Over here, 20.24, 20.24, 20.2. Gate to drain or gate to source is 0.20. So this one here has a direct short between gate and source. So what I'll do is I'll just kind of flip it up just to let me know which one it is. The rest across this is reading 20 ohms there. Oh, found another one, 0.22 ohms. So this one here is shorted. 20 ohms and 20 ohms. So again, that was the biggest questions I get is how I can diagnose these so quick. So typically when I get an amplifier in for repair, I can have it diagnosed within the same day. When on the warranty repairs, it doesn't matter. I don't have to go back to the customer and let them know and shoot them my quote because I don't proceed with any work without an approved quote. But these warranty repairs, it's just real quick. I just figure out what's wrong. 7.17K. So this side here is going to be more than likely good. So you're going to have the 7K across the gate and source on a good side. From your positive lead on the gate. This is how I read that. And you can go the other way around too. You can put your negative lead on the gate, so you're going to read 6.1K. And 9.1K. You put your ground on the gate. But it's really, I've just done so many of these that I just recognize right off the bat when there's something wrong. So this bank here has a short. So typically when these transistors short, you're also going to take out the drive IC. Delayed? It's the weather, isn't it? God, the weather's just been killing shipments. And then I get them in bulk. So instead of getting them in every day, I'll get piles of them in like twice a week. No, I'm trying to keep up with chat at the same time here, guys. So Daniel, I don't know the background of this amp. I don't know if he's a competition guy, how he ran it, whatnot. So what he had hooked up, I'm not quite sure. Do you want Rockford Fosgates? I do very few Rockford Fosgates. You want to know who works on Rockford Fosgates? Talk to Crazy Logic there. Damon, he could point you to guys in the right direction. I know George on Facebook. You'll find him on Facebook. He does a lot of Rockford Fosgate stuff, or he does JL Audio. I repair pretty much anything. I don't do a lot of MTX and Kicker. I don't like their designs. I don't like how they're built. They take a ton of time for me to troubleshoot just by design. So some of the Kickers I don't do, and some of the MTX I don't do. Hey, Big Stone, thanks for dropping by. The non-bass. Hey, Daniel, you know, I'm going to look into that because even on my even on my amplifier repair sheet, all I show is Smart 3, Smart 5. So I I really don't know about any other versions of the smart amplifiers when it comes to repairing them, I should say. I just don't have a lot of time to research all the amplifiers out there. I really am busy from 6 a.m. till 9 p.m. with this stuff. So sometimes I wish I had employees. So I have two bad transistors. I'm going to fire up my good old FR301 here and get these two pulled out. And what my next objective in this warranty repair is to see if I have to replace the IC. So my next goal is to pull the bad transistors and see if my resistance value goes up to my 7K that I would like to see. If it does, that means none of the Zehners failed, and I go through and I check the Zehners too. Those are really susceptible when it comes to shorts, but I think this had what I call a light short, not a drastic failure. Some amps I get in that are just burn up. I just did a 12K where it burned a hole completely through the board at the inductor, at the output inductor, and believe it or not, everything survived on that amplifier. No bad ICs, no bad transistors, no bad Zehners, nothing. And it was a 3/8 by 3/8 hole that was burnt right through the board at the inductor on that 12K I just did day before yesterday. And man, it was amazing that it survived. So we get this 301 all heated up here. The capacitors on this one in particular are 2200 microfarad, 200 volt. On this amplifier here. So I'm just gonna flip it on over. Oh, and a little trick here, guys. On these boards, I don't want to say they're thin, but they are kind of thin. I have a little foam pad that goes underneath the board to keep the board from flexing as I flip it over. On the other side, you have your rail capacitors that keep the board from flexing on you. But when you're on the flat side, I like to put something in the middle to keep the board from bowing and flexing in the middle. So I've got the two transistors there. As you can see, I bent them up. Tells me which ones they are. And you'll have to excuse the noise, guys. And also, guys, please remember I do have two very large dogs here that may bark at noises, so just keep that in mind for you guys that wear headphones. Oh, what do we got here? I think, don't quote me on this, but I think the spreader was screwed down so hard that it popped the side off this transistor. It doesn't look like it got into the die at all, so so that's the two bad transistors pulled. And let's go ahead and check my positive on the gate, negative on the drain. 7.2, 6.8. Well, I'll be darned. Pull those two out, and then I get the resistance value that I'm looking for. Again, I have my little foam pad there to keep the board from flexing. Oh, drive chip numbers. You bet. Damon, let me just back up on the chat here real quick. It's my watch Bearface comparison video, and this is a little but I learned from him. Oh yeah, oh, oh Sam, yeah, good old Sam there. You'll find him on Facebook. Yeah, he's a great guy. I started watching Sam. It was probably early 2019 when I found him, and I've been watching him ever since. He's a great guy. Sorry, I'm still trying to catch up on my morning coffee too. Drive chip numbers. All right, here we go. I'm blind here, guys, so let me. I'm just gonna have to get in here real quick and see what we got for drive chip numbers. Hopefully, you guys are all writing this down for people that need reference. So your drive chips are going to be the IRS 2957 for your output drive, and of course this uses the PIC that goes over and drives the gate driver. So your gate driver is that the gate driver on these smarts? Oh my goodness, hold on, it is not. Oh, it is. I can barely read these. Hold on, let me check them out real quick. Wow. The 2N8524? Those gate drivers? I do believe so. Oh. Oh, am I that close? 33 more? Oh my gosh, so close. I mean, it's crazy. I never thought in a million years that I'd have 1,000 people subscribe to me. My primary goal with this was just to help educate people because manufacturers do not give you information. Of course, unless you work for them, but they don't. Maxonics, I had to sign an NDA with Maxonics to get a simple schematic from them, which I don't mind signing an NDA. I really don't. Like if I won't share their schematics, of course, but again, I had to sign an NDA. It's just manufacturers. They're just not willing to let schematics go. So my main goal for this channel was to help educate and let people know how the amplifiers work, what's in them, what's used. So the drive transistors, the outputs on these are the IRFB 4127s on the Smart5 here. Yeah, manufacturers drive me crazy. I'll work for them if they're good. Otherwise, I'll just stay independent. So your power supplies are going to be the 180 NF6s. So pretty common, pretty typical. So let me see here. We had good. Let me check the Zeners and the gate resistors that are in this locations where the shorted transistors were. $10 ohms, and the other one 10 ohms. And the Zener for that one is 7.2. Let me go to my diode mode here just to make sure the forward voltage on it is okay. 6350. 50 silicone. Come on, tar amp. 135050. This Zener here, unfortunately, did not make it. 1.32. So it looks like I'm going to be changing out the Zener for one of them, and of course it's got to be the one underneath the inductor. Never fails. Hey, old school. Thank you for subbing to this channel here. What amps you run if you have a build? What amps do you run if you have a build? I just repair amps. Um, I used to be in sound competition many years ago, and I just sorry guys, but I realized I needed my ears, and I can't hear very well, so I just repair amplifiers now. I used to do installs back in the early mid 2000s. I had a business called Wired Audio where I did custom enclosures with install plus car alarm, and I got out of that after a couple of years due to manufacturers' vehicles being so hard to integrate. So 6 to hey, thanks for dropping by. Oh, Vince, yes. Oh, I'm a huge supporter of Vince. He is another great person. I've seen him go a long ways. All right, guys. So I'm gonna flip this back over because now that we pulled the 2 transistors out, that Zener. Hold on. Am I gonna tackle that Zener now, or am I gonna tackle that Zener later? I have to cut silicone out, and there's one thing about I don't like to drag you guys through a bunch of mud, so yeah, silicone. Thanks, Taramps. All right, let me just check and see what we have in parallel here. Rule of thumb, amplifiers. If you're going to replace transistors in amplifiers, replace the parallel banks. So let's see what we got here. And how unfortunate is this? So this here, this here is one bank, right? And yep, this, hold on, 1, 2, 3, 4 is one bank. So as you can see, we have one missing out of each bank. So these are going to be matched through both banks. So what I'm going to do is I'm going to remove the rest of one bank, fill the spot here. And the good old Hacko FR301 here. The great little brother of the 808. I still love my 808, don't get me wrong. But parts for that thing are getting a little hard to find, so I've been babying it for a long time. It's, you need to pull something large like terminals. The 808 is the tool to do it. I don't mind the 301 here. It's just a single diaphragm, so it's really not up to the large tasks. And with that single diaphragm, this lead-free garbage that they use, it just wreaks havoc on the pump. So there's the 3 that I pulled. And I don't like thermal paste. Another pet peeve of mine is when they just drench these boards in thermal paste. And I don't know, you know, people that understand the aspects of the, I don't know, how would you put it, the thermal dynamics of thermal paste would know that too much thermal paste actually works against you. So I'm just going to test these real quick. let's see here. 416 at half, 416 at half, 46 at half, perfect. And 416 at half, excellent. That's what I like to see. So then I just utilize the transistor to fill the spot. And let me go grab the transistors from the bin here. So I love working for Tar Amps. They supply me all the parts. Down Got Wild. Yeah, he's another great guy. My wife laughs whenever I'm watching him. She loves his accent. Hey, Andy. Good to see you here. Let me just grab some transistors real quick. These were the what? 4127s? These are the 4127s. All right, so let's see here. The 4127s. So I need 1, 2, 3, 4. One, two, three, four. 4127s. Just like that. And then what I do is I grab the old. What I do is I just grab an old transistor here, line it up with the new transistor, take the flat side of my tweezers, and give it a little bit of a bend there. That way it just matches the board. These kind of set up a little bit in the heat sink, so you don't want to get the legs too short on these. You don't want to add any stresses to the legs of these as the amplifier goes through heat cycles. You just want to make sure that your repair has durability written behind it. And just line them up, make sure they're about the same. I know, I'm pretty meticulous in my repairs. One of the biggest statements I have is I can't stand returns. If something goes wrong, then you know, of course I repair it, but I can't stand returns. So the better job that you do, the less of a chance it's going to come back on you. Keep things clean. Orderly, and then understand the stresses that these boards go through. The more you understand the stress that these endure, the higher likelihood that you'll have less of a failure when it comes to like a transistor leg breaking. And on these boards, the holes are slightly wider than a TO220 package. So I also bend the leg just a little bit to the side to fit those holes. Again, it comes down to making sure you don't have any stress applied to the legs of those transistors. Then I just Give just a little bit of solder on the leg. Hold it in place. Sorry if my hands are all in front of the camera there. Yes, I very much agree with that old school. Attention to detail. I watch uh I watch a lot of other people, and it's it's odd what I see sometimes when it comes to the details, the fine details of what they're doing. A lot of times I say in my own mind, I say, whoa, hey buddy, you might want to slow down just a hair, uh, on what they're doing. Let me see if I can get this into view here for you guys. So what I do is I just solder one leg, and then I go through and I line up the transistor. That's factory. And remember, they stand up off the board just a hair. You don't want to make them flush with the board, solder them in place, and then when you go to screw this thing back down to the heat sink, it pushes all those transistors back up. Again, adding stress to the legs of the transistor. And then once they're in about the right area that I'm looking for, again, if you notice, I'm using the 301 here to solder them back in place. I like to say, hey, if you have the heat here, use it. This tool will do more than just suck solder out of the hole. And I have this set, my 301 is set at 1.5. So another thing that just destroys traces or vias is heat. Like the old Phoenix Gold M100 that I did. Man, I tell you what, that thing was sensitive to heat, about pulling off the via top to it. So you just got to be super careful when you're using heat on especially some of the older boards. Like I've got a oh, what is this? I have a Phoenix Gold that I'm working on currently, this Precision Power, this Pro 650. Immaculate condition. Poor guy, but you're almost afraid to touch the board with a hot iron, because you could pull a via or pull a trace. Like, it's gonna be one of those boards where I just gonna have to take my time and make sure I do everything perfect on it. Oh, hi, Cardi. Oh, better at this live chat thing. Oh, yeah. I'm not a social person at all. But I do these to try to help answer any questions, because I get a ton of questions every day, and sometimes I just run out of hours in the day to answer questions. So let me flip this back over. What do we got here? I just want to make sure that we have the right readings that I'm looking for here. Let's see. I replaced this bank of 4. Did I? Let me go back to my resistance mode. Again, I like to look for my pull down resistors. That's really what I'm looking at. 6.7, 6.7, 6.7. 7, perfect. 7, perfect. 6.8, perfect. So those are looking great. That Zener though, I'm really questioning the Zener down here. Of course, anytime you pop one of these amplifiers, you really should question the Zener. 9.2, 7.1. Yeah, all right. 6. Let me just verify the neighbor here. 6. Yeah, I'm so what is this? D15 down here underneath the inductor. Again, I go by resistance readings. So let me just kind of give you an idea here. I have 9.1, 9.1, 7.1, 7.1. Oh, actually, I am actually maybe right. 7.1. Oh, because this is your low side and your high side. Oh, okay. Never mind, guys. Whew. I was starting to sweat on that one. It's because I'm on the other bank. Nice, nice. So, typically when these fail, that short goes through your gate resistor, goes back up through your diodes, goes back into the drive IC. But I have a sneaky suspicion that this drive IC is going to be fine. You start to learn when you have a resistance value that is off, you start to learn that it's off because of something behind the transistor. I call it behind. So something back in the drive. The resistance values should really always look the same. So let me get my 10 amps. This, you know, these Smart5s here, it may blink twice at me for low voltage. I've noticed that on these smart amplifiers that sometimes my power supply will drop just low enough as these start up to kick it into a low voltage protection mode. But we're gonna find out. And the remote circuit. And my scope. Hold on. Oh, I don't have the scope up for you guys. Do you want the scope up or not? Because I can sure pull it up for you guys if you'd like. Let's see here. I have old words. Add foam to help limit vibration to the FETs. Oh yeah. I'm not afraid to show my screen up when fixing stuff, you know, leaving the power supply on while change drive transistors. Oh, yeah, I saw that on that video there, Damon, that power supply was still running. I have done that many times, and I'll be like, oh, why is this transistor heating up in the power supply? And then I look over and I still have my power supply running. Yeah, probably not a good idea to have your power supply functional while you're doing a repair. Oh, how nice. They left me some copper in the remote turn on here. I'm just going to check real quick here. And the thing about these smart amplifiers too is your dial is on the bottom. Like, oh my gosh, give me some LEDs on the top here. Tell Taramps that, hey, we need some diagnostic LEDs on this. Well, the fans came on. That's a good thing. Let's see here. Let's let me pull up the scope here for you real quick, guys. It'll take just a second here. And hopefully I don't lose too many resources where the live stream starts to lag. All right. Well, the fans came on and I can't see the diagnostic LEDs because it's on the bottom of the board. So let's, what am I on? 2 volts. Let's go to 5. And let's see, do I have any form of gate drive on this? Yep, I sure do. All right, so let's get the time base set up for you guys here. What is it? 20 microseconds, I do believe, is the time base for these drives. So the fans come on, and then you'll hear the fans kick off. Whew, I got some nasty pull down ringing on that. Good old smart amplifiers there for you. Where's my, get my trigger up here. So as you can see, we do have, you do have your drive and your rail to rail. Rail to rail. Sorry, these aren't rail to rail. With no, I know you're not supposed to run these with no load connected, but there is your drive there for you. So my last thing I'm going to do is I'm going to take my thermal camera and I go through and I check your, I check the diodes. I got a kink in my neck that I had. I check the diodes and the Zeners. If you have a diode and a Zener that is out, I should say out of tolerance, it will heat up. It won't heat up to a point where the transistor won't work or go into failure, but it will get hot. Yeah, old school. You know, when I first started this, I would get amplifiers in, I got them in on the pallet. And I went through and I learned every aspect about that board that I could. And many transistors, many resistors later, I have all this equipment now. Oh, well, hold on. So I have a TG167 here. That's what I use for my imaging. Oh yeah. So there is a transistor that's heating up right here. This guy right here is heating up. So why is he heating up? Is it a... Did I miss a value? Hold on. Yeah, and guys, again, as I always say, keep your fingers out of the rail voltage. Just be cautious of what you're touching. I don't know what the current voltage is right now. I mean, there's hopefully got a pull down on it. I get these in, I get them out. I really don't know, but I'm sure there's hopefully a pull down. Let me check. Oh, nope. So yeah, so just to give you an idea, when I say keep your fingers out of the amplifiers, so this amplifier currently, well, now it's got 109, had 115 volts on it still. So it does have a pull down. It's a relatively large value pull down right here. 4702, 47000, so 47K pull down resistor. So there was 115 volts here, and it was been a little while since I had the power off. So just to remind you guys, keep your fingers out of the rails here. You don't want to have a bad day. So something is heating this up. I just want to make sure it's not a Zener. What do we got? It's probably going to show me because I have voltage on it. Yes. The joys of discharging rails. How much current do you think is behind this? Probably a lot, huh? What's my voltage? I use a rather large 74 volts. It's a 200 watt, 2 ohm wire wound ceramic resistor. The thing's about as long as this board, and about 1.5 inches in diameter. It's a really large resistor that I have mounted down below me here that I use to discharge rails if they're not going fast enough for me because I need to get this done. .65 volts. And 2 volts. So I just touch just these two together. Dissipates that voltage and current right through that resistor, so it brings me back down to a 0 volt there. Let's see what's going on with my... those darn Zeners. Yeah, you know, every time you're gonna... More than likely, you got to replace them. And... Oh, you know what? Do I have a bad transistor here? Did I miss one? Did I miss one, guys? I probably did. Oh, darn it. Yeah. Hold on. I got myself another bad transistor. But... Oh, but where is it? Hmm. Did I miss that transistor? That's kind of interesting if I did. Yeah. Yeah, 12 ohms. Gosh darn it. Hmm. Well, that's not very nice. Oh, it's Chico. Hey. Thank you for dropping in. Are you the one that sent me the amplifiers out of Florida? I think I remember a Chico on my website. Sorry, I deal with a lot of people. Uh, uh, where? Hey, Damon. Do you think I really did have a bad Zener that just took out my transistor? Or do you think I just had a bad neighbor? I may have had a bad neighbor. All right. Let me, yeah, I know. Probably a good rule of thumb to replace the Zeners too, right? Probably. Uh, Let me just see if I can keep you guys in view. Sorry about that. Let me just see if this is the one that... Oh, no? Oh my gosh. Seriously. What? Ah. 21, 22, 22. Where are you? Hold on. All right. I'm going to have a bad Zener. I knew it. I should have went with my first instinct of thermal paste. Ah, I know. I repair amplifiers and I can't stand thermal paste. Isn't that ironic? It literally gets everywhere. Let's see here. I'm just gonna pull these so I can see if it's a Zener or not. It probably is. Which was causing all that nasty low side ringing on the drive. Do this without pulling out a rectifier here. There we go. All right. Well, hey, the IC survived. He's an all across ignition resistor with an there you go, yeah. You know, and that's one of the hardest things to find are large resistors that work good with car audio. I mean, sure, any resistor can work as a discharge resistor, but that's one thing I found when I was starting this business is the load bank. Uh, One of the biggest hurdles I had to deal with. Oh yeah, 115 ohms with them out. Um, was the load bank. So it took me a long time to figure out the how to set up a good load bank to test these, 20K amplifiers. Trust me, it's tricky. Ugh. All right, so, oh, Let me just do a quick check, make sure none of the transistors hit. Could be. Could it be a bad drive IC? No way. It wouldn't be a bad drive IC because I would think the amplifier would go right into protect. Oh, well, hold on. Shoot. I think I did. Let me double check. All right. This is what happens when you miss a transistor. Let me see here, get in the view. There it is. Unfortunately, darn it. But now I do not have the right values that I'm looking for. 10K. Oh, do I have the right values? Hold on, I may. 10K, 10K, and 10K. Because what's your pull down value? Your pull down value of 10K. 747475. Let me check the Zeners. 129. Oh, 129. One five. Oh, hold on. 20. Yeah, see, these numbers are not even close to being correct. Oh. Uh, 10, 10, 10, 10. Ten, 10. Ruh-roh. Yeah. Technical specialist. Thank you for joining in. It looks like I am going through either I had a shorted transistor, this guy here, that I must have missed, and now nine two six 6 6 927 so 928 929 3 9 9 3. So let me put the transistors back in. You know, Jamaica. DJ Bell, hey, thanks for checking in. Just going through a Smart 5 here. Amplifier on the good old live stream that he decided to do here. So what I'm doing is I'm putting the transistors back in to check my values on the diodes. So more than likely I'm gonna have to replace their 15-volt Zeners. Which is odd because most times when I get good values, resistance values, I don't have any issues with Zeners. But I've seen that though, you know, you'll get that little bit of a glitch. Oh, where's my foam? There it is. Again, I put that foam in the middle to keep the board from flexing. All right, 5, 9, 10, 5, 9, 10. 5, 9, 10. Good. So, good. Excellent. Maybe I did have just that bad. Can't believe I'd miss a bad transistor. I didn't put that bad transistor back in, did I? I've done that too in the past also. You pull out your bad transistors and you end up reinstalling them. So I just want to make sure, I just wanted to verify I did not reinstall the bad transistor. Goes in the bad pile. I've done that and it's like, oh my gosh. So then you gotta, you know, find the bad one, unsolder it, put a good one in. So now what I'm going to do is I'm just going to check my values. 6, 1. 6, 1. And then the good side. 6, 1. Pull down 10. Good. 6, 1. And your pull down of 10. Good. So if I fire this up and I lose another transistor, what would you guys go to next? I don't think I'll lose another transistor, but just saying. Let's see here. Rectifying diode, those hardly ever go bad. Oh, no. I haven't replaced any rectifiers. I haven't had to replace a rectifier in a long time. Yeah, that's true. They very rarely ever fail. It takes something significant, really, for a rectifier to fail. Let's see here. They go bad a lot more in the full bridge. Yeah, you know, I have had to replace a ton of rectifiers in the Sundown amps, the SFBs. I don't know what is up with their design, but hey, Sundown, I think you guys need to figure it out because I have had to replace a lot of rectifiers in those boards. And there was a Sundown board that I did also that had the surface mount rectifiers. Oh my gosh. I just, Sundown, you need to figure it out. Let's see here. Well, where was I? The remote. Where? All right, so back to the 10 amp current limited power supply. Make sure I have my voltage set up perfect. Now, I know it's got drive, so the first thing I would check is heat. I know it's got drive, but what will you end up seeing first before a failure? You're going to see something get really hot first. So I just want to make sure that I don't have any heat build up here. Again, with my TG167 imager. And I'm just going to watch this side as the amplifier powers up. Oh, there we go. Beautiful stone cold transistors now. Most excellent. This guy right here. This guy right here is getting a little warm. And that's what I love about using the thermal imager. Um, Again, this goes back to preventing future failures. This transistor here. So now these, again, watch your fingers, guys. So you're going to have what? What are we going to have now? We just turned it off. So let's get our voltage here. I'm huge on safety, 138. So when you guys are testing these boards, don't touch the rectifiers. So these transistors are nice and cold, just the way I like them. With no load attached, you shouldn't have really any thermal issues. I mean, besides your voltage regulators and stuff that are naturally will get hot, you shouldn't have any heat problems. Nothing should heat up, really. If something heats up, then, well, you might want to check that circuit. So I'm just letting the transistors cool down real quick. I wonder if I can show you this, guys. Let's see here. Kind of hard. Sorry, I have a ton of light above me. Let's see here. I'm just gonna fire it up real quick. And I'm gonna watch that transistor. And there it goes. There it goes. Creeping up, creeping up, creeping up, creeping up. Yep. All right. So, and is that the only transistor? So this one here is heating up. And this one here's got a little bit of heat on it. Just a little bit. Let me go ahead and fire it up again and double check the side that I just repaired. Oof. Yeah. So remember I was talking about that really heavy negative drive ringing? I do believe that the negative drive ringing is going to be causing, because what I got is I got a little bit of heat here, and I do have a little bit of heat here. And I have that negative drive ringing on both sides. Is that because there's... So is this something where I would just go ahead and replace the drive ICs? Probably. Yeah, old school. Yeah, that's what I'm thinking. That when it went down, some of these, oh my gosh, thermal paste all over. Some of these did get damaged or a little there. It has signs of leaking, that's for sure. So I'm probably going to how am I going to tackle this one? Um, could be a bias. Um, could be. That's good. That's a good point. Let me check and see. Bad cat. Nah, I'm not so sure about that. Um, um, let me discharge the rails real quick. This one is being finicky. Now this one might pop a little bit, guys, so watch your ears. Ah, just a minor pop. All right, let me make sure I don't have any real voltage here that'll give me a bad day. Nope. All right. So, what was I gonna do? Oh, let me double check and make sure that I don't have a, no, 6-7. Hmm. Where? Come on now. Oh yeah, this one's gonna be finicky on me now, isn't it? Uh, it sure is. Gosh darn it. Yeah, this one is not 9-5, 6, 6, 6. Oh my goodness. 6, 6, 6, 10. There's my 10, so that's what I expect to see there. But yeah, I think 3. Oh, there it is. 10. 10 to 6, 6, 5. Oh man. Yeah, this one's all over the place. Uh let's see here. Follow your gut. Pull them all. How did you guess? Oh, you were reading my mind. Ugh. Yeah, dang it. Pull them all, check the drive. So I'm finding the Zeners aren't bad, but 6, 7, 6. But I am going to be suspecting the drive ICs for this. Yeah, so I guess it goes back to you can fix the initial problem, but when the problem occurred, it like I'd mentioned before, it goes through the gate resistor, goes through the diodes, goes and it ends up back at your drive ICs. You know, and 9 times out of 10, yeah, I got to replace the drive ICs. And I saw that really nasty low side ringing. So yeah, so before I damage any more transistors, it's gonna be the safest bet to pull them all. And verify the drive. I'll get drive just for a brief second. When it tries to start. Because I don't know if these smart amplifiers will go into protect if it doesn't see that feedback. Probably will. I mean, sure, I could pull up the schematic on that, but again, I don't like to drag you guys through the mud, so. Yep, drive feedback. Yeah. Ugh. Let's see, where's the feedback circuit on this? It is right here. So here's going to be your feedback circuit. Ugh. So when the output shorted, sometimes I will get damage back through the feedback circuit, depending on the drive signal going to the drive ICs. I've had to do a few repairs on the feedback circuits, but not very often. Usually it goes down to failure at a drive IC, but I'm seeing the same value on both sides. So this is where I'm starting to get a little concerned that 6.8, 6.0, 6.1. See, I'm not seeing my 10K anymore on both sides. Yeah, 6.8, 6.8, 6.8, 6.2. He's gonna be like, yeah, you know, you just might as well pull them all out or replace the drive ICs. Take your pick, huh? Do you guys want to go over replacing a drive IC, or do you want to go through the pulling out all the outputs? I think it's funner to do some SMD soldering myself, personally. ICs first. All right. All right. ICs first it is. So we're discharged. The good old Amtech here. We're going to go ahead and prep this up. Hey, Basehead, hey. Thanks for dropping in. I see you've been watching some videos. Hey, thanks for checking them out. And I saw you over on Derek's channel, Wilson Audio Labs, I think it was. I saw you on popping a comment down on one of his. So, good to see you here. Yeah, DJ, I am on it right now. We're just going to go ahead and fire up the old Hacko iron here. All right. Bear with me, guys. Again, this was a, you know, what do you call that when you just decide to do a live stream? Spur of the moment live stream here. As I fire up all my equipment here to do some SMD work. And of course, drink my coffee. All right, so 380, 40%, preheat the board. And again, why do I preheat the board? Just going down to the fine details, you know, of makes things easier. If you just preheat the board a little bit. I'm going to use SRA on this. And I will show you guys how I do this. I mean, I could pull the chips with hot air, but nah, I don't like to do that. I don't like to get a lot of hot air around the capacitors. So what I do in a situation like this is I just pull out the old SRA here. This is your low melt, low temp, low melt, whatever you want to call that. Sorry for the noise there. Low temp solder here. Clean up the tip. Apply the low temp. Get the tweezers ready. It doesn't take long. Pull the ICs on these. And I just drag that SRA across the leads of the IC until it pops up. And then what I do is I take that SRA, I come and I just transfer it over to the next IC. You're not going to get it all back onto the iron. You're going to end up having some at the traces here. Or traces, excuse me, the pads. And this is why I preheat the board. It's a lot quicker to pull your ICs with low melt, low temp solder. Otherwise, you're going to be sitting here for a few minutes waiting for all those pins to heat up, and yeah. So then I'll just drag this across, wait for this one to free up. And just like that. And I set all this stuff aside. And I do that for a reason because, again, I do warranty work for these guys. So I have to keep track of everything I do here. So you'll see me just kick everything off to the side. Use the solder braid here to pull up that low temp solder. You don't want to leave any of that behind on the IC for the new IC. Because you just never know how hot this amp's going to get in the vehicle that it's going in. So try to get all of that low temp pulled as much as possible. Beautiful, just like that. And that is how I pull ICs. And that's not the same process for every board that I do. For instance, I have these in full warranty repair. So this is one of their 400 by 4s, 440 by 4. So this is a 440 by 4. And I tell you what, guys, if you ever get these in for repair, you gotta have a good hot air rework station to work on these. You should. I mean, you will save a ton of headaches. Star amps. So I would use hot air, of course, to pull and repair the ICs on this board, which I got to do. Waiting on parts. So in this situation, I didn't use hot air to pull them just because of the proximity of all the electrolytics around it. Okay, let's catch up on this here. Check the AC first. No loss. If it's not, then it's close up. Yes, be right back. Yeah, you bet, old school. Nothing wrong with being spontaneous. Yeah, thanks. How good is the Hacko desolder? Oh, with lead free? Well, you gotta always keep it clean with lead free. That's probably one of the only gripes I have about the Hacko desoldering tools. Probably any desoldering tool in that case would be the use on lead-free solder. It's a pain. I clean my desoldering tool probably once. I clean the whole thing probably once a week. But you're constantly always cleaning out the heater in it. And yes, my good old trusty Q-tip here. I like to clean up all the old flux so I can inspect the pads. And I just want to make sure, again, it goes back to making sure you have all the low melt pulled up. You don't want that new IC going on the low melt. Clean. I like everything clean. Let's see here. It would be nice if the manufacturer would implement a digital display showing a fault code that you could easily look up under the jail. Yeah, I agree. All these PIC based amplifiers, believe it or not, they don't do a heck of a whole lot in these. For instance, on the tar amps boards here, they drive voltage regulators, they drive the power supply, and of course it drives the output drive ICs. And that really all it does. It does have, I think pin 1 is the output for your fans. It does regulate the fans. It uses a pulse width modulated signal for the fans on some boards, not all boards. And it does have the output for your LEDs. So with those removed, I'm just going to check my resistance values. Because if my resistance values are still off, then I'm going to be forced to pull the transistors anyways. All right, so what do we got? 665, 65, 64, 10, 98, 98, 64, 58, 65, 6, 66, 66, 65, 10. 5967. 5866. All right, so 6 and 5, 8, 10. Good afternoon. As it would save a lot of troubleshooting time. Yeah. Oh yeah, you bet, Cardi. We'll we'll see you again on the future. Next one. Next video. Yeah, I'll be back. So, I'm thinking. Sorry, guys. I'm just thinking a second. Just thinking. Let me double check the bottom. I'm just not. Uh, 6, 7. I'm not. Why am I not seeing my pull down on these? Why am I not seeing my pull down value? I should be seeing my pull down value. Hold on. Give me 2 seconds here, guys. I just need to double check a number here. Mm-hmm. 6, 6. 6, 6. 6, 6 against the pull down resistor is not the number that I'm looking for, is it? 6, 8. 6, 8. 6, 6. 6. I think he's going to be right. I'm going to end up pulling the transistors on these. Just to double check the circuit itself. Yes, the output, the IC drives the outputs directly. Directly? Good question. Let's find out. So the outputs comes through. I think they may be using a... Are they? Are they using a... See, that's the thing about these smart amplifiers. They are probably not using the drive directly. But I am going to find out. 10 ohm. So they're not. They are. Oh, hey. Fancy this. Who mentioned that? Who mentioned that? Farouk Thomas. I would like to mention something. That they don't drive it directly. Very, very good. I want to say thank you for that. You know why I want to say thank you for that? Because you may have just saved me a huge headache. Mm-hmm. Are these guys using? Oh my goodness. Ah, hey Damon, are you still in the chat here, Damon? You wouldn't believe I did not know Taramps was doing this, but you wouldn't believe what's in between the drive IC and the gates. Is it? Is it the 3005? A 511A. They're using a drive IC. Uh, uh, yep, they sure are. Well, you know, Damon, that's a good question. I don't know what the factory number is for the 3005, but these are labeled 511As, and they are using a 6-pin. Oh, these guys. Okay. So backing up. When you have failed gate or failed transistors that shorts through the gate, which again, that's what I check for on my resistance values when I first diagnose an amp, is I always check gate source. Because usually what shorts out in a transistor first is that little thin gate trace in there. So it shorts the rail voltage back through the gate, usually takes out the gate resistor, depending on the short, and goes back to the drive IC, but there's a 6-pin in between the gate and the drive IC. Let's see here. The next biggest question is, did Taramps give me these parts? Sorry guys, I just gotta check my trays here real quick. I may have to message Alex because I only have a schematic for the Smart 3. Do I? I think I only have a schematic for Smart 3. Let me see if I have any 6-pin drive ICs for these guys. Does anyone know what that would be? The 511A? You know, I'm gonna highly doubt. Oh, nope. This isn't looking good. Not looking good. I do not have any 6-pin. Oh my gosh. All right, guys. Which is probably the 27511. They are pretty good about sending me parts. I've got a ton of stuff from these guys, but I don't remember seeing in my inventory lists these 6-pin gate drive ICs. So remember how I was talking about that low side ringing? That really now is pointing back to, since they're using a gate drive IC, a short in the gate drive ICs. So let me double check here. So IC 12 is a 6-pin gate drive. Yep, so there's my 10.23 ohms, which is your 10 ohm gate resistor going up to the drive IC, and then you're probably gonna have, without knowing exactly what this is, Well, so what do we got here? So pins 2 and 3. Pins 2 and 3 on this gate drive IC are, oh my gosh, 2 and 3 are together. Those are, yep, sure enough, I have 31K on this gate drive IC, and I don't on this drive IC. Ah, darn it. Yeah, I do. So I have 31K all across that. Okay. So whoever mentioned that, Farouk, I just want to say thank you for bringing that up, because I do believe I have a bad gate drive IC, which makes sense. If you ever work on sundown amps, you always got to replace the gate drive ICs. But I don't know if, oh, that 511A, let's see here, 27511. Borrow one from another. If I had another Smart 5 here, I would. Oh, I don't know if I have a Smart 5 board here though, from Tar Amps. Which is a good reason why I was getting such bad drives here. So, seeing how I had gate drive on both sides of the output ICs, and if there was any excessive ringing on the drive itself, so I would end up replacing the gate drive ICs and probably both output ICs. I'm just surprised I don't have those gate drive ICs. Ugh. That's a real bummer. That is a real bummer. All right. No, they don't. Then that's what I love about the Tar Amps boards is they don't use ICs in between. That's why I'm surprised this one has it. I don't remember even seeing these on the Smart 3. Hold on, give me just 2 seconds. I do have a Smart 3 over here. All right, guys, hold on. I'm just gonna double check because I do have a Smart 3 that's also in for repair. So I'm just gonna double check and see. I just don't remember seeing a gate drive IC. Maybe I just going too quick on my repairs here, I guess. Slow down, Todd. Slow down. I know. Hold on, let me see what this has. So this uses the 2957, correct? Oh, they do. Oh, these guys, they're using the 511As. Yep, sure enough. Yep, both sides. Ah, they are using gate drive ICs. I should have these in inventory then. Why? What? Hold on. Am I just missing? Oh yeah, I know, right? Because if it's got the same issue, then I don't have the ICs for them. Like I just can't believe that they would not send me gate drive ICs. Uh, uh, I would pull up a browser and pull up what Damon mentioned, the 27511. Oh my gosh, I don't have gate drive ICs from them. Thanks, Taramps. Well, okay. Well, guys, I apologize. I don't have that particular IC. Oh, I have, let's see here. Do I say it in the chat or not? Damon, I do have another 100 coming. I probably have about, 60 left in stock. So my supplier does have the 3005s, just to let you know. Well, oh, so if you have time, oh, I got time, Farouk. If you have time, let's pull the outputs and check the amp drive. We can if you'd like. I don't mind. If is someone available to pull up a data sheet for me on the 511A? Is it at all remotely the same as a 3005? I do have 3005s in stock. I just don't know exactly what the 511 is. I would assume it's gonna be the same as a 3005. So if it is, what I'll do is I'll put some 3005s in if they're the same, and then have Taramp send me replacements. That's a bummer. Now I'm gonna have to let the customer know that I'm gonna be on standby with his amplifier. That's not good. I don't like that. Customer satisfaction, of course, is always my #1 goal for anyone that gets my emails. Hold on, I'm just putting away my SRA here. All right, let's get these things pulled out. For all you guys that are willing to hang around and bear with me here. Yeah, Farouk. So I think that's what I'm going to do is I'm just going to go ahead and pull the outputs. I'm going to put 2 new drive ICs on, and I will see if it'll give me a drive or not. I don't know if it will give me a drive. It might briefly give me a drive. Thermal paste. Ugh. Lead-free solder. That's a double ugh. again, if I can use 3005s, I'll put 3005s in. And that's the thing about working for, you know, people in Brazil is the time difference really puts a little barrier in communication time, because by the time I figure out what I need in a day from them, it's nighttime. So a lot of times I have to wait till the morning. I'm gonna make sure I don't pull any rectifiers out here. Okay. So I just will have to send Alex a message. If there's any tar amps repair guys here, you probably know Alex. All right, there's one side. No, not pin for pin. Gosh darn it. All right. Hey, thanks, Damon, for looking at that for me. Hey, Mike, how's it going? Yeah, that's a real bummer. Darn it. I'm gonna have to. I need to send Alex a message because I have parts ordered for these 440 by 4 amplifier. Because I don't have any of those SMD transistors that they use in those 440s. So I had to order those, and maybe I can catch them quick enough. I can get these gate drive ICs in. Oh, sorry about that, guys. At the same time. Oh, that's true. Yeah, Cliff. Yeah, I wonder if Cliff's got some. I don't know. Cliff's the only one guy that I know of that I deal with quite a bit for tar amps repairs. I know there's other guys, but I do know Cliff pretty good. Yeah, that's what I'll do. See if Cliff's got any. Sure he does. You can always tell by the sound of your desoldering gun too, when it starts to let you know, hey, you're getting a little too much flux residue in the desoldering gun and the pre-filter. So hopefully I can make it through all these without having to replace the pre-filter. Probably not gonna make it. Oh no, I'll make it. And as it is, this one's taking too long for me already. You know, most times I can get these amps diagnosed and repaired within an hour or two. Just depends on how complex the problem is. Oh. So now I will flip it back over and let's see here. Where are we? We are on the output section. All right, all the transistors are out. All right, let me just check my values here one more time. 6 5 6 5 6 5 7 6 5 7. Perfect. Should be 10K 10K 6 6 and 6 7 and 6 7 and 7 and 10K 9 3 9 4 9 3 6 6 7. Okay. I do believe I'm going to have faulty gate drive ICs, just to let you guys know. Just based on the values that I'm reading on the resistance here. So sometimes all the Hacko needs is a bit of let it to wash down the garbage solder. Yeah, that's true. Oh, what part are you looking for? I'm looking for the 511A gate drive IC. 6-pin IC. That's what I need. I do believe I have a faulty gate drive ICs. It just depends. I'll know a lot more if this will give me a signal if I reinstall the output ICs. Sometimes I'll sit here. Oh, when the white filter gets plugged, slice of the area of the razor. Oh, you know what I do, Damon? I actually have a whole pile of them. I replace them, and I have a little container here that I use that I soak them in isopropyl, and then after they soak, I will rinse them underwater, and I wash out the pre-filter on that. I've had the same pre-filters for, oh gosh, I probably had these for, I'll have them for a year or so, probably 8 months on the pre-filters. Let's see here. Where was I? Drive ICs. These were the 20957s, right? I do believe so. I don't know. Let me see here. 20957. I can't even read it. Yeah, the IRS 2957. Got lots of those. IRS 2957. Time is it? Gotta watch time. 10:40. All right. So what I'm gonna do, I'm just gonna pop this drive ICs in, see if I get any drive without the output transistors. There are ways you can fire up the circuits without the rail voltage, but I think I'll just replace these drive ICs here and see if it does give me a drive signal, even for a brief second. Let's see here. Pin 1, pin 1, pin 1. Make sure you put your ICs in the right direction. And pin 1, pin 1. Wish I had my close-up camera for you guys so I could show you a little bit closer what I'm doing here. Unfortunately, it has decided it wanted to no longer function. So I am stuck using my normal camera. And I just tack down the corner to opposite legs. Pretty simple. ICs aren't that bad to do. Although the trace with the ground plane on it is quite cold, so I may have to heat up the board again. But let me get these other pins nailed down real quick. Beautiful. It literally just takes a second. Unless, of course, you're on the ground plane pin there. So if I had any suggestion on the key to soldering ICs is flux. Flux is your one of your best friends when it comes to soldering. And just like that. And of course, the trusty Q-tip here to clean up the IC so you can double check the solder joints to make sure there's no solder bridges. And I want to be careful when I fire this up too. I don't want to damage uh, any of the new drive ICs. So it looks like I have some solder next to a pin here. So we're gonna try to free that up here. I can't quite tell what I got going on here. There we go. Nice. All right. Well, what we got here? So, hey, Chris. Hello, hello. Do you check the turn on resistance when you touch FET with your fingers, or a waste of time? Do I what? Turn on resistance when you touch FETs with your fingers? Do you check the turn on resistance? Oh, when I check with my fingers? Oh, that's just a really quick, if this is what you're talking about, it's just a really quick thermal uh, test. So what I do is I look with my thermal imager, and then what I do is I physically feel the transistor, the one I'm seeing on the camera and the one next to it, just to feel the difference in the temperature. I don't look at the temperature on the screen to tell me what the temperature is. I just go by feel. So that's what I'm feeling for, to see how hot it, in reality it is. Uh, no 511As. Thanks, Mike, for looking. That's crazy. I just, it still baffles me that I don't have those. All right, so back to the test. Again, this may not work because it doesn't have, it's not going to see any feedback. So let me make sure there's nothing around here that's going to short anything out, because again, these rail voltages get substantially high. Me just see what we got here. I'm just going to set my probe in here real quick. And see if it's going to give me any drive. No. It will go under protect though. Yeah. Okay, yeah, that's what I kind of figured. So it's not going to give me anything because there's no feedback. It's not very nice. That's a real bum deal there. Yeah, not very nice. Yeah. Well, guys, I need to contact Taramps and have them send me some 511As with the parts for the little 400 or 440s by 4s. So that's just not very nice. I mean, I could put, no, that's not going to gain me. I mean, I could put one transistor in per bank per side. to see if it was just bad drive ICs, but 9 times out of 10, I find that it's the gate drive ICs that are bad. And I'd hate to solder and desolder a million times in the same via. So what do you guys think? I use XTG SP2. Oh, let's okay. Just to eliminate if it was a bad drive IC. Just to eliminate that. I'm going to test 4 transistors. All right, 4, 6. Whoa, what? Hold on. What is this? What? This is a 4127, right? Yeah. Am I reading this right? Oh my goodness. No, 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 no. That can't be right. Hold on. I'm gonna have to show you guys something here. What? What? What is going on here? All right, all right. So the transistors that I pulled out, what I thought was the good side, had a bunch of transistors. The RDS is showing anywhere from 1.6 ohms to 4 ohms. 3.8 ohms? Oh. Hey, remember when I was saying I had that low side 5.6 ohms? All right, hold on. Let me get my other meter here real quick. 59545. Okay, all right. 0.5. Oh my gosh. So it could have been I had leaky transistors, guys. These are so I got these are showing up as, IGBTs anywhere from yeah, 1.6 ohms. 5.1 ohms. Yeah. Okay. So can you guys 5.1 ohms? It's hard to sorry, my camera's not focusing, but so this is coming up as an RDS of 5.1 ohms. I'm just showing you guys. This is the bank that I thought was good to go. And let me just show you some of these tests here. Any IGBT. Oh, and any IGBT with an RDS of 0. Okay, hold on. N-channel MOSFET of an RDS of 4.7 ohms. Okay. Yeah. Any IGBT 4.7 ohms? What? Hold on. Now, let me check the transistors that I installed new from tar amps here. Hold on. So, oh yeah, 1.3. So maybe, oh, that wasn't a new one. I did have bad, yeah, so 0.5. So these are what I would expect, 0.5. Any N-channel MOSFET, N-channel MOSFET, 0.5. Oh, so someone had mentioned leaky transistors early on. So that was the one that was getting hot, which has an RDS of 1.4 ohms. This one's 0.6. Yeah, okay. Geez, Todd, how about you just test your transistors? Yeah, me neither. I use these as a quick reference because they're really good at just showing me a shorted transistor. But usually, when I see when I go through and I look, see this one had a line on it, so this one here was heating up on me. When I look at the RDS, that's kind of what I look for is the short and the RDS. So let me yeah, so I just use them as a quick reference. Quick. I just need to see which one. So Easy 97 of the originals. Easy 97. All right. Let me grab four 4127s real quick here. Oh, and I'm going to turn the power supply off. This is just so I can just check the drive. So I'm gonna get myself back on track here. And discharge the rails. Again, you don't want to take out and install transistors with rails that are charged. And what I'm going to do is I'm just going to put one in per side. And hopefully the smart circuit doesn't rely on gate resistance values or circuit capacitance because I don't have all the transistors in. Thermal paste. So this will allow me to, hopefully, allow me to at least start up the ICs. But if there's going to be excessive ringing still, I will replace, of course, the gate drive ICs, as they would be one of my suspects in a failed output section. So, and don't. There. See, now I'm like everyone else, have transistors laying around everywhere. Well, never fear though. I'll get it all cleaned up eventually. So let's go ahead and, uh-oh, phone call, hold on. Hold on. All right, let's see if we have dry. I'm gonna have to go here real quick, guys, but I just want to see what we got. For the output section here. Much better. Much better. Maybe. Oh yeah. Oh yeah. So, let me I'm just gonna check with my thermal. I think it was, guys. I had some transistors that didn't completely fail, but they failed enough to where, yeah, they were probably leaking. So let me just double check, make sure we're not getting too hot here. Nope. Nope. Well, so I do still have some pretty good ringing on that. But again, that's probably because there's no load on this for the feedback. And they are cold as can be. So, yep. MK328, MK328, MK328. So, yeah, on something like this, where I have transistors that got past me on my initial testing, but yet are failing in circuit, so they're leaking, I would just dispose of all of them and replace with all new transistors. So that's what I'm gonna do, is just replace all the outputs on these. And that, guys, I'm gonna have to run. I got to catch up on the phone calls real quick here, customers. So, I'm going to contact TARAMPS and have them send me some gate drive ICs to be prepared in the future. Cold as can be. So that's where, yeah, check your transistors. I mean, so when I was showing, 5 ohms, 5 ohms on one and 0.5 ohms on the other, and I test it multiple times to, to eliminate tester error. When it keeps coming up as 5 ohms, there's something fishy with it. I would call it fishy. So I'm going to go through and just test all these and just kind of get an idea of what happened to this, so I can report it. I think it's just going to be an output failure on this with multiple leaky transistors. So Guys, I do thank you guys for dropping in. If you have any questions whatsoever, please feel free to give me a call, email me. My website, www.ellensburgamplifier.com, has all my contact information. I'm more than happy to answer questions and help anyone out in repairs. So thanks for watching, guys. Keep your fingers safe out of the real voltage here. Strong stuff. We'll catch you on the next one.